Yeah, hello and welcome back, guys. In the last section, I showed you how to make use of the GitHub repo to see the solutions, and we thought a little about the results of our first app. What I do want to mention really is that we made only use of React until now. And React has this principle where it has a state. So we don't really have an action here. We had an action on the click button, and with this action we modified the state of the component, and then this step we can overjump the state, update the view, and this was how we made use of it. As we have seen, it is complicated, and this is where Redux comes into play, because I want you to think about let's do it with this slide. I took this slide from the internet because it has a very valuable information for us. You might ask, what is the condition for a React component to render itself, or better, to re-render itself? So what needs to happen to enforce the render cycle? How is when data is passed in? And there is a simple answer for this. The answer is, if the state of the component is changed or the props are changed. There's a diff, and if there's a difference between the previous props and the next props, or the previous state and the next state, then the component will render itself and will update with the changes. We need to keep this in mind. How do we update a component, or how do we enforce a re-render on a component? We update either state or props. So let's go to the next slide. I want you to really know it. There are two things that force a re-render or a render on a component: a change of either state or props. Let's take an example. If you have bound the state via the change method to an input field, it forces a re-render on update of the properties. Or another way is, and we had this in our Pokemon app, the parent component receives a new state and passes it down as props to the children. If there's a new prop into the children, then it also re-renders. Please keep this in mind for later. I want you to really know this. State and props of the component. A change in either of these forces a component to re-render. Okay, now Redux comes into play it's quite handy. The state is quite a challenging thing, and the tree can grow very big. So this is where Redux comes into play, because Redux provides us a global store. In this store, every information about the state of the application is inherited. So all data is bound here, and all components that listens to the store and receiving new props are updating. I want to show you a quick diagram of how this works. I named the diagram UDF because of the unidirectional data flow. So let's check this out. The unidirectional data flow starts with the user. The user is often here. This is what the user sees. The user sees the UI. And the UI, the user in some ways interacts with the UI. He or she presses a button, puts some data into a form, uses a slider, using select boxes, whatever you can imagine. And interaction with the UI triggers an action. We will build these actions later. These actions are sent to reducers, And these reducers will update the store. This is the Redux global store. And this store contains the state of the application, which there defines the UI. So what happens? Let's say the user clicks a button here. Make something red. Let's say make something red. This triggers an action. Make something red. This action is sent to the reducer. The reducer will update the store and say, hey, something happened. We need to update the store. Make this thing here over there, make it red. And the store updates the global state, and the UI is listening to the global state, and so it re-renders. I want to show this is a little bit small, but let me show you another. Picture. So I will use the browser to enlarge it. It's nearly the same principle, but a little bit prettier, right? So let's say you are here, you are the user, and this is your UI, and you somehow interact. You click a button here, you know, this is some little bit wrong. The arrow should be from here, from the UI to the action, but the user is interacting with the UI, so the user is in between, and the user then an action is thrown, and the action will part of the application state. For, let's say, you want to provide, in this example, a new movie, and then an action is given to the reducer, and the reducer is only updating the state of the application that is related to anything with new movie, you know, because if you want to bring a new movie, but you are in the Pokemon app, and you only are in the movie section now, you don't need to update anything about Pokemon, but you need to update anything related to a new movie. So it updates the part of the application state that is related to the new movie, and then the updated data is sent to the store. The store keeps track of all data in our application. You can imagine it as it's written here, it's one big JavaScript object or also a big JSON object. Yeah? It's a really big object, and it keeps track of everything. Then we will pass it down the provider. We will see the provider later. The provider is the highest point of our app if we are using Redux. The app is wrapped by the provider. And this gives us guarantee that every component that is inside the app is listening to the store. The provider brings this data down to the containers. So containers fetch the app state data and use it to render or display components. We will see it later on. And when the application state changes, the components are updated. So let's say you are a user and you are viewing here in this list. Imagine the Pokemon app. You have a list of Pokemon. So you have a list of new movies now. And as a user, you click a button, you type some form in, you make an action, you're providing a new movie, and you're giving it the title from avatar, and you're saying the genre is action. Then, as we see, the reducer is adding to the movie array. Here's the array part you can see. It's adding it, and then it's updating to the store. The provider sees, I have a container listening here. The container is, let's say, list of movies or list of Pokemons, list of movies in this case. And he sees, there's a new, something changed here. So it forces a component to re-render. And the component itself contains the mapping over, the iteration. So the new movie would now be listed here.